Hello, this is example 6 of trigonometric substitution. So on this example, we have to integrate x dx over x squared minus 4x plus 8. So this one is one of the special ones, one of the special trigonometric substitution where it requires completing the square and putting it in vertex form. Okay, so yeah, so what we're going to do first is um, we're going to rewrite x squared minus 4x plus 8 in vertex form by completing the square. So how do we do that? I'll show you. So the first step is move the constant to the right. So you're going to subtract 8 from both sides. Okay, put a blank space. And then on the right it's -8, so put a blank space here. So what do I put in that blank space? You take half of your b. So if your b is -4, take half of that. That's -2. And then you square that. So -2 squared is 4. So you're going to add 4 here, add 4 there. So you get x squared minus 4x plus 4 equals to -8 plus 4 is -4. Is that true? Yes. Okay. Then what you do is you kind of like have to go backwards. You're going to put this in factor form. So to put this in factor form is simply x and then half of your b, which we said was -2. Square equals to -4. Then the last step for completing square is move this constant to the other side. So you're going to add 4, add 4. So you get x minus 2 squared plus 4. Okay, so you're going to rewrite the bottom as you're going to rewrite this as parentheses x minus 2 squared plus 4. Okay, now that we did that, now we have to use the appropriate trig substitution. So this whole thing here is very similar to it's very similar to x squared plus a squared. So that means we're going to use the substitution x equals a times tan theta, right? So what do you think our x is going to be, and what do you think my a value is going to be? So I believe our x is not just x, it's actually this whole thing, x minus 2. And I believe our a, or a constant, is what number squared gives you 4? I'm going to say 2. Okay, so my x is going to be x minus 2. My a is going to be 2 times tan theta. Okay, so what we're going to need is, well, we're going to need an x minus 2 square. So let's do that real quick. So it's just squaring this. So 2 squared is 4. Tan theta square is tan square theta. Okay, and then what else do we need? Well, we'll probably need, do you see this dx? We'll probably have to put everything, we got to find dx. So if you go back to here, the derivative x in respect to theta would be dx d theta. The derivative of -2 is 0. Okay, and then on the right side, the derivative of 2 tan theta is well, 2 is a constant, so you could just take that out, and then the derivative of tan theta is secant square theta. So the derivative of this whole thing is 2 secant square theta, right? Then what you want to do is solve for dx. So you're going to have to get rid of this d theta by multiplying both sides by d theta. Okay, so this cancels, so you're left with dx equals to 2 secant square theta d theta. So now we have everything what we need. So we can replace x with, oh, we don't know what x is. Well, we know that x minus 2 equals to 2 tan theta. So just regular x would be 2 tan theta plus 2, right? Okay, so we have everything we need. So we can replace x with 2 tan theta plus 2. So you're going to replace that. So it's 2 tan theta plus 2 times by dx, which is this whole thing, 2 secant square theta d theta all over, uh, so on the bottom it was, what is x minus 2 squared? It is 4 tan square theta, and then don't forget you have a plus 4 at the very end. So the bottom would be 4 tan square theta, and then plus 4 at the very end. Okay, so what I do next is I would simplify the numerator by FOILing out the numerator. So go ahead and FOIL 2 tan theta plus 2 with 2 secant square theta d theta. So that would be 4 tan theta times secant square theta plus 4 secant square theta all over 4 tan square theta plus 4. Okay, so is there anything else we could do? I guess we could start factoring and canceling. So on the top, what can we take out? We could take out a 4, and I believe we could take out a secant square theta. Let me take that out. I'm going to factor out a 4 secant square theta. And then you're missing a tan theta on the top, tan theta, and then a plus 1. And then on the bottom, you have 4 tan square theta plus 4. So is there anything you could take out? Yes, you could take out a 4. So this would be tan square theta plus 1. Oh, wait, is that all we? Yes, we can. So what do you see that cancels, and is there anything we can substitute? Yes, I see the 4 that cancels, and then I also see that tan square theta is a Pythagorean identity. It comes from this identity, right? 1 plus tan square theta equals the secant square theta. Okay, so what you're going to do is just replace this with secant square theta. You're going to rewrite this as secant square theta the tan theta plus 1 stays true. And then on the bottom, so the 4 cancels. So then on the bottom, you can replace tan square theta plus 1 with secant square theta. And what do you see that cancels? The secant square theta, right? So you're left with tan theta plus 1 times it by d theta. Okay, so What is the integral of tan theta plus 1? Well, you can break it into two separate integrals, right? So this would be tan theta d theta plus the integral of 1 d theta, right? So let's take an integral of this. So I can rewrite tan theta as sine theta over cosine theta times by d theta plus, and then I know the integral of 1 or a constant is just theta. So on this one, I might have to do u substitution. So I believe my u would be cosine theta. And then my du would be negative sin theta d theta, right? Okay, so it's going to be, it'll be 1 over u, and then thing is, we have to get rid of this negative 1 because we have only a sine theta d theta. So to get rid of this negative 1, we're going to multiply both sides by negative 1. So this is negative du, and then this is sin theta d theta. Okay, so you're going to multiply this by, you're going to replace sine theta d theta with negative du. So this is, you could factor this minus, so it would be a minus, and then it's 1 over u du. Okay, so the final answer would be minus, and then what's the integral of 1 over u? It's ln of u, and we said our u was cosine theta. Plus theta, then plus c. Now, is this our final answer? No. The reason why it's not our final answer because our final answer has to be in terms of x, so this is where we have to draw our right triangle. So to draw your triangle, so what we were given was we were given x minus 2 equals to 2 tan theta, right? And what you're going to do is let's solve for tan theta. So what we need is cosine theta and regular theta. So first, I'm going to just finish the triangle. So this 2 cancels, so you're left with tan theta. And then on the left, it's x minus 2 over 2. Okay, so we have tan theta. So if you forget, you can write that out to SOHCAHTOA. So what is tan? It's opposite over adjacent. So this x minus 2 is your opposite side, and then this 2 is your adjacent side. So here's your theta. So this x minus 2 belongs here because it's on the opposite side. This 2 is adjacent, so it's right here. I think we need to find the hypotenuse because we need to find cosine. So yeah, we'll have to find hypotenuse by applying Pythagorean theorem. So Pythagorean theorem is x minus 2 square plus 2 square equals c square. So x minus 2 square is x square minus 4x plus 4, and then 2 square is 4 equals to c square. And then you get x squared minus 4x plus 8 equals to c squared. And my c value is so my hypotenuse is x squared minus 4x plus 8. Okay, so what did we need? So we need to find cosine theta and theta. So let's find cosine theta real quick. So cosine theta is adjacent over hypotenuse. So our adjacent side is 2. And then my hypotenuse is that whole thing. And then theta is, well, we know that tan theta is x minus 2 over 2. So you just, to find regular theta, you have to get rid of this tan by multiplying both sides by tan inverse. So your final answer is going to be tan inverse of x over 2 over 2. Okay, so our final answer is going to be, so it's negative ln of cosine theta plus c. So your final answer will be negative 1 ln, and then our cosine theta was 2 over square root of x squared minus 4x plus 8 plus theta, which we said was tan inverse of this. And then plus c. Okay, so those are your final answer. Okay, yeah, that's our final answer. So I will stop here.